Hi there, welcome to Caltex Academy. Today on our board we have an exponential question that talks about given 16 exponent p times 8 exponent q over 4 exponent p plus q equals to 2 exponent n. Write down an expression for n in terms of p and q. So we can see there's some relationship between 2, 4, 8 and 16. So let's write down our question here, and we have 16 exponent p times 8 exponent q over, and let's use a ruler here for organized work. So this is divided by 4 exponent p plus q, and this is equated to 2 exponent n. Now let's pick the largest number here, and you can see that our largest number is 16. So we can write 16 in exponent form by using this factor 3. 16 by 2 goes 8. Then 8 by 2 goes 4. 4 by 2 is 2. And 2 divided by 2 is 1. So we can see that, okay, 16 can be expressed in terms of 2 as 2. How many times has 2 appeared if we multiply to get 16? So therefore here, now we have 4 equals 16. And we are seeing 8 here, which means we can also have this in terms of 2. So we have 2 exponent 3 will give us 8. And 4 in terms of 2 is 2 exponent 2 equals 4. So these are the major numbers we find from the left hand side. So let's go ahead and write them in terms of power form. Now we can have here 2 exponent 4 to the power of p times 2 exponent 3 to the power of q all over 2 exponent 2 to the power of p plus q, and everything is equated to 2 exponent n. If you have a to the power of m, and the whole of this is raised to power n, this can be written the same as a to the power of m times n. Using this rule, we can apply here, and we have 2 exponent 4 multiplies p will just simplifies to 4p. Then the second one is done in the same way. We have 2 exponent 3q, and we divide by the denominator, which I think we can divide. We can simplify this again to 2 exponent. So we have 2p plus 2q. This is equivalent to 2 exponent n. When we have a base of a to the power of m, and we multiply it with another one of to the power of n, this will be the same as we maintain 1 and we add. So it is m plus n. So we apply it in the numerator of this question here, and we have maintaining 1 base, which is 2 to the power of 4 p, and here we're adding, so we also add the next one here, and that is 3 q. So we're still dividing this with our denominator, and the denominator here still happens to be 2 exponent twice p plus twice q, and this is equated to 2 exponent n. Now There's also another rule of indices. We can get it another sticker here, and we say, okay, if you have a number a to the power of n, and you divide this with another number a to the power of n, this can be given in one number as n minus n. Meaning when you divide numbers with the same basis, you simply subtract the powers. So from this rule of indices, we can apply it here, and we have 2 exponent 4 p plus 3 q, and we're subtracting two numbers, so we can give it here 2p plus 2q equals to 2n. Now we can go on and open up this bracket, and we have 2 4p plus 3q minus 2p minus 2q equals 2 to the power of n. Now what we can do is to just simplify. So we have 4p minus 2p, we have here 2p, then 3q minus 2q, we have q, and this is equivalent to 2 exponent n. So since we have now collected this into one spot, we can move on and equate the powers since the bases are the same also. So let's do that by putting that statement down here, that since the bases are the same, we equate the powers. And now here our powers are just 2p plus q equals n, which is what exactly the question was looking for, where we have written n in terms of p plus q, and that is our result. So thank you for watching up to this time. See you in the next video. Peace out.